In this video, I'm going to give you a brief orientation to multi-criteria decision analysis. It begins here in Cameron Run. You see Cameron Run here is in Alexandria, Virginia. And this is a little urban creek that causes some flood problems and has some minor opportunities for environmental benefits, ecosystem restoration, if you will. Um, and so Cameron Run is not all that long, and here it is, excuse me, emptying out into the Potomac. But in any event, that's the basic um, area that we're interested in. We had the Baltimore District did this, and they identified a number of plans, just designated A through H. And what we did in the analysis was we had an overall goal of selecting the best plan, and these were the criteria that we were going to use. Annual habitat units created by the plan, user days of urban recreation, the cost of the plan, the flood risk management measure was expected annual damages reduced, and then there would be potential effects on property. So I'm going to show you the data. Here are the data, plans A through H, as you can see here, and these were the values. There are quantitative data for 4 of the criteria, and the property effects would be high, medium, or low, where the effects would be positive. So high would be a positive effect on property values, increasing property values. Now let's go back here to this model. When you input data, just not teaching the software, but just give you a little feel for this multi-criteria decision analysis, how it works. We have a scale here, and we can say what is most preferred. So the maximum number of habitat units produced by a plan was 116, so that was most preferred. And the least preferred would be the plan that had 0. That's useful because sometimes you get criteria like cost here where you want to reverse that, and the most preferred would be a small number, the least preferred would be a big number. So that's a nice little feature. So we've got these criteria, we've got these data. We entered plans A through H, and so now what we need to do is we need to tell people of these criteria which are the most important. So up to this point, multi-criteria decision analysis is just a nice way to kind of organize your data, get you to a decision matrix and all that sort of thing, all very nice. But now what we need to do is we need to figure out what the weights are, which of these are most important, and this is where multi-criteria decision analysis runs into issues. This software offers many ways to assign weights. We're going to use the simplest, a direct entry here, where we just say what the weights are. So here I'm going to say we've got 4 measures of benefits and 1 measure of costs. So I'm going to say benefits and cost are equally important. So I'm going to give cost a 0.5. Now I'm going to rescale this just to make it add up to 1, as you see here. And I'm going to say of these remaining, let's say that flood risk management is the most important. We're going to make that a 0.25. So that means I have a 0.25 to spread over these others. And let's do it with a 0.1 just arbitrarily. But this is the problem. This is arbitrarily. And who gets to say what they are and how they are? And that's why you don't find people using multi-criteria decision analysis too often. Because there are homeowners who will say, what, only 5%? For the effect on my property value, and they won't be happy with that, and so it would go. So I'm going to say I'm done now, and you can see the relative weights. So all I need to do is now go up to the software, and I'm going to go to the results, and I'm going to say rank these alternatives. Use the data that I gave you, use these weights, and would you calculate which plan is best? So it's saying, what do you want me to rank? And I'm saying, give me the overall rank. And I click OK, and it says, all right, well, plan D, that's the best plan based on the criteria you gave us and the weights of those criteria. And then plan B would be the least effective. The bars here show you just visually which plan is most effective. And the nice thing about this is it's color coded. So I can see the Plan D here. This little red bar, not so big. Plan D really doesn't do so much on flood risk management. Uh, we've got property effects, does a good job, really helps the property owners there. We get a lot of annual habitat units, does pretty good for recreation, does okay on cost, but not so much for the flood risk. You want flood risk, that's Plan H here. That does a lot more for the flood risk, but notice that yellow, property effects, and the, what else was missing there? What else? Got red, got green, got blue. Okay, so yeah, this doesn't do much on cost. So this is the most expensive plan, and it doesn't do much for property effects either. So you can kind of get an idea when you look at a plan visually here, like Plan B. This is good for flood risk management, and it's pretty good for cost, but it doesn't do anything for others. So we could toss Plan B out, or we could say, is there any way to reformulate this? Is there anything that we can do to add some of these other features to the plan? So it's kind of nice that way. But we have that argument about what the weights are or should be. So if I go up here to the results and I pick a dynamic sensitivity, let's do the overall sensitivity. I've got weights down here, and this enables me to play around with weights. So suppose I'm going to say, let's see, the homeowners think that this is most important. So if we increase this to 31%, how do the plans change? I should have paid closer attention. I don't remember what was at the top before, but now we got Plan D at the top. If someone comes in and says no, it's actually annual habitat units. It's environmental. Let's see, we got DFG. Look at the order up there. And I'm going to say that's the most important. Well, now we got DGH and then F. So you can play around a little bit here. You could go in and change these weights to any values that you want. Annual user days, if it's recreation, then Plan G rises to the top. If you're saying, nope, it's flood risk, that's what's most important, then Plan H is up there. So you have the ability to dynamically fiddle around with the weights. And of course, you could just go back in and change the weights to whatever set that you like. There are a couple of other things that are relatively useful. Let me see if I can go back to, let's close this out, and I want to go back to my weights. Okay, maybe we're not going to go, there it is. Go back to my weights. They are as I liked. I'm going to go back to results now, rank them again just to get back to the original set. And here we are, back with Plan DHG. So as we look down through here, I can look at, for example, ranking results overall. This will blow your mind for a second, but this is basically, each plan is a color, okay? And we can see the overall ranking. The highest ranking is the black plan. That would be Plan D. So then I can see the second best plan overall is the red plan, Plan H. So this is for overall ranking. But I have the ability to go in here now and say, okay, for flood risk management, the red plan is ranked highest. That's Plan H. And you can see the other plans are all relatively close together. So the colors here, if I go to annual habitat units, I can see that this plan can't quite make out that color. I think that's Plan A, is it? Plan A is least effective. The yellow plan here, Plan F, is somewhere in the middle, so that you can look at each criterion and find out what the order of the plan's contributions to that criteria are. So if this is blowing your mind a little bit, I don't mean to be doing that so much as trying to give you a way to see how you could use multi-criteria decision analysis to play around with the decisions. So playing with the weights is probably the most effective thing to do. And when you look in here, there are a great many different ways of doing this. sensitivity graph. If I put cost up there, I selected cost. So this line is showing me the current weight for cost. So at the current weight for cost, this blue plan here, plan D, is best. And then plan, I guess that I'm having a little trouble pulling that out. That looks like plan H is next best for cost. You could imagine, though, if the weight was over here, you could see how that order changes. Here we had plan A, is it, was best when the weight for cost is low, but as the importance of cost goes up, the desirability of plan A goes down. So it's kind of handy that way. It's a neat tool, but the problems are, as we've talked about here, is how do you assess these values? This is where people disagree, and that's where the plan falls apart. By the way, I should have mentioned that it is possible to input these values, this 10, it is possible to do that. Let me see if I can go back here to our matrix. It's possible to put these values in as a distribution instead of as a point estimate. So it does have that capability as well. I've gone way too far on multi-criteria decision analysis, so let's call a stop.